Hi students, this is Sivakumar, 10th standard mathematics, chapter number 1. In chapter number 1, so far we have completed exercise 1.1. Now exercise 1.2. Before doing that exercise 1.2, you must be knowing the concept of relation. That means two objects are related under some specified rule or specified condition. Come on, two objects are related under some specified rule or specified condition. I'll give an example, you can easily understand. I'll give you two examples. Example number 1. I take Chennai is a capital of Tamil Nadu. So how will you write symbolically? Chennai is related to Tamil Nadu. Okay, this is called a relation. Two objects, one is Chennai, another one is Tamil Nadu. Both are related or refers relation. Even we can say that Chennai and Tamil Nadu in the form of a set of ordered pairs. Chennai and Tamil Nadu. Okay, I'll give you one more example. 2 is an even prime number, correct? You know very well, in set of all prime numbers, 2 is a only even prime number, correct? So it can be two objects, one is 2, another one is even prime number, both can be related. 2 is related with even prime number. Okay, this can be written in the set of ordered pairs 2, even prime number. I hope that it's a very simple only. I hope that you have understood the concept of a relation. Now, I read one definition. Listen. Definition of a relation. Let A and B be two non-empty sets. Yeah, you know the meaning of non-empty sets? Empty set means a set which has no element. Non-empty means a set must have at least one element. That is the meaning of non-empty. Okay, how many sets totally? 2 sets. A relation capital R from the set A to the set B is a subset of A cross B. Very important one. The relation is a subset of A cross B, satisfying some specified conditions or specified rule. If X belongs to the set A, that means X is an element of A, is related to Y that belongs to the set B through capital R or refers relation. Then we write in the form of X is related to Y. X related to Y if and only if X comma Y is an element of R. If and only if, very important one. That means if X is related to Y, X comma Y belongs to R. If X comma Y belongs to R, X is related to Y. That is the meaning of if and only if. Very important. Next one. The domain of the relation R equals set of all X belongs to the set A such that X is related to Y for some Y belongs to B. Codomain of the relation R is the set B. The range of the relation R equals y set of all y belongs to the set B such that x is related to y for some x belongs to A. Okay, look at the difference between the here x belongs to A for some y belongs to B, that is for domain. For the range, y belongs to B such that for some x belongs to A. From these definitions, we note that domain of R is a subset of A. It's a symbol for subset. Subset of A. Codomain of R is equal to B, and the range of R is subset of B. Again, domain of R is subset of A. Codomain of R, that is equal to set B, and the range of R is a subset of B. So, while working out the problem, you can understand the concept of the relation. No need to worry. Here one example. Here you are given two sets. Look at that. Let A equals 1, 3, 5, 7. You are given the set in the roster form. How many elements are there? 4 elements. And B, that is equal to 4, 8. Here we have 2 elements. Look at that. If R is a relation defined by is less than from A to B. Listen carefully. This is a rule, specified rule. Is less than from A to B. Then 1 is related to 4. Obviously, because what is given is less than, correct? 1 is less than 4. Since 1 is less than 4, 1 has to be taken from set A, 4 has to be in the set B. So 1 is less than 4. Similarly, you can write 1 is related to 8. 1 is related to 8 because what is the rule? Is less than, 1 is less than 8. Next, can go for 3 is related to 4. 3 is in the domain and the 4 is in the codomain. This is the domain, this one is the codomain. You have to obey the rule also. 3 is less than 4, 1 is less than 8 and 1 is less than 4. 3 is related to 8. That means 3 is less than 8 according to this rule. And 5 is related to 8. 5 has to be in the set A and 8 must be in the set B. Finally, 7 is related to 8. 7 is related to 8. 7 is less than 8. Equivalently, you can write R, the relation R equals, you can write them in set of ordered pairs. That is, 1 is related to 4 can be written as 1, 4. Similarly, you can write 1, 8, 3, 4, 3, 8, 5, 8 and 7, 8. You can ask me, sir, why don't you write 7, 4 and 7, 5, 4. Why don't you write 5, 4 also? If you write 7, 4, 5, 4, that condition won't be satisfied. What is the condition? Is less than. Suppose I am considering 5, 4. 5 is less than 4? No. 5 is greater than 4. So you are not supposed to take 5, 4. Understand? Now, this is very important note. Listen carefully. In the above example illustration, A cross B. You know A cross B. How to write A cross B? Already I have learnt in the previous exercise. 1, 4, 1, 8, 3, 4, 3, 8, 5, 4, 5, 8, 7, 4 and 7, 8. Here you are given A cross B. But we have R. Look at that R. We have 1, 4, 1, 8, 3, 4, 3, 8, 5, 8 and 7, 8. So look at that. We see that R is a subset of A cross B. Obviously, 1, 4, here it is. 1, 8, here it is. 3, 4, here it is. 3, 8, here it is. 5, 8, here it is. 7, 8, here it is. So all the elements of the relation R in A cross B. So we can say OR is a subset of A cross B. Very important note. Okay, I hope that you have understood the concept of the relation. The next video I'll be teaching exercise 1.2, first problem. Thank you, children. In the previous video already I explained the concept of relations. Now problem number 1. Here you are given two sets, both the sets in roster form. We have to verify each and every relation is a relation from A to B. You have to verify R1 is a relation from A to B. Similarly R2, R3 and R4. You can verify. Solution. Subdivision number 1. Before verifying each and every one is a relation, first you have to calculate A cross B. Set A is 1, 2, 3, 7. Here it is. Cross set B, that is equal to 3, 0, minus 1, 7 equals. Already explained the concept of cross product of A and B. Two sets. 1, 3, 1, 0, 1, 3, 1, 0, 1, minus 1, 1, 7. Do you remember? Next, 2, 3, 2, 0, 2, 3, 2, 0, 2, minus 1, 2, 7. Next, 3, 3, 3, 3, 3, 0, 3, minus 1, 3, 7. Finally, you have to take 7. 7, 3, 7, 0, 7, minus 1, 7, 7. A cross B is over. Okay. After that, subdivision number 1. In subdivision number 1, you are given R1 that is equal to 2, 1 and 7, 1. Very simple, listen. 2, 1. Already I have told, if it is a relation, that relation should be a subset of A cross B. Correct? So 2, 1 here it is. No, 2, 1 over here. Then 7, 1. No, 7, 1 over here in A cross B. If at least one element of the relation, R1, doesn't belong to A cross B, we can straight away tell that is not a relation. Listen. So 2, 1 belongs to R1. 2, 1 is in R1. But the same 2, 1 doesn't belong to A cross B. Correct? In A cross B, no 2, 1. Therefore, R1 is not a relation from A to B. Understood? Now, subdivision number 2. In subdivision number 2, you are given R2 that is equal to minus 1, 1. Okay. Only one element, minus 1, 1, that is a element. Minus 1, 1 is not in A cross B. Look at that. No such element. How to write? Since minus 1, 1 belongs to R2, but the same minus 1, 1 doesn't belong to A cross B. So R2 is not a relation from A to B. Okay. Now subdivision number 3, R3 is given. R3 equals 2, minus 1, 7, 7 and 1, 3. Okay. 2, minus 1, Here it is in A cross B, correct? 7 comma 7, yes, here it is 7 comma 7. 1 comma 3, even 1 comma 3 is in A cross B. Very simple. So obviously each and every element of R3 belong to the set A cross B. So how to write? Since R3 is a subset of A cross B, you can directly write R3 is a subset. It is a symbol for subset. A cross B, R3 is a relation from A to B. Subdivision number 4. Subdivision number 4, R4 equals 7 comma minus 1, 0 comma 3, 3 comma 3, 0 comma 7. Okay, you can verify one by one. 7 comma minus 1, no, yeah, we have 7 comma minus 1 in A cross B. Okay, 0 comma 3, 0 comma 3, 0 comma 3, no 0 comma 3 here, no 0 comma 3. Okay, so 3 comma 3, yes, we have 3 comma 3. 0 comma 7, 0 comma 7, no 0 comma 7. Here already I told you, if at least one element doesn't belong to A cross B, then we can say that is not a relation. Here we have 0 comma 3 and 0 comma 7, both don't belong to A cross B. So since I take only one element, you don't take both 0 comma 3 and 0 comma 7. I take only one, that is 0 comma 3 belongs to R4. 0 comma 3 is in R4, but the same 0 comma 3 doesn't belong to A cross B. Can verify once again. 0 comma 3, look at that, this is A cross B, correct? No 0 comma 3 over here. Straight away write R4 is a relation, not a relation from A to B. So first subdivision, not a relation. Second subdivision also not a relation. Third subdivision is a relation. R3 is a relation. And fourth subdivision, R4 is not a relation. So problem number 1 is over. I'll be teaching problem number 2 in the next video. Thank you, children. Let A equals 1, 2, 3, 4 up to 45, and R be the relation defined as square of on A, right, or as a subset of A cross A. Also find the domain and the range of R. Set A is given. What's the condition? Defined as, or is defined as a square of. It's a very important one. That is a condition given. And R is a subset of, right, R is a subset of A cross A. Also find the domain and range of R. First we can find A cross A. Set A, that is 1, 2, 3, 4, etc. up to 45. Cross again 1, 2, 3, 4, etc. up to 45. Here suppose A has n elements and A cross A, that is equal to n squared elements. Here we have 45 elements. Here 45 into 45, 45 into 45, that is equal to 2025 elements will be there in A cross A. You no need to write everything. You just write 1 comma 1, 1 comma 2 is going on. The last one is 45 comma 45. It is enough. No need to write all 2025 elements. Okay. Now the first one is the relation R is a subset of A cross A. Therefore, here what's the condition given? A square of. So I consider by data, by condition, I consider y as x square. So what's the condition? Square of. So that you consider y equals x square. In set of ordered pairs, the 1 comma 1, the first one refers x value, this is a y value. So here x value is 1, y value is 2. Here x value is 45, y value is 45. Therefore, R equals, how to write R according to this condition? I am going to replace x by 1. Okay, 1 squared, that is equal to 1. X value 1, replace x by 1, 1 squared, that is equal to 1, that is a value of y. So 1 comma 1 over. Now I am going to replace x by 2. 2 squared. 2 squared is 4. Substitute x equals 3. 3 squared is 9. That is the value of y. Substitute x equals 4. 4 squared is 16. Now substitute x equals 5. 5 squared is 25. And substitute x equals 6. 6 squared is 36. Okay, that's all. If you replace x by 7, what will happen? 7 squared is 49. No 49 here. In set A, we have the elements up to 45. So you are not supposed to take 7. So R is over. Okay. Next, domain of R and range of R. Domain and range of R. Very simple one. Domain, that's a, look at the first element. What's the first element here? 1, 2, 3, 4, 5, 6. That is a domain of R. 1, 2, 3, 4, 5 and 6. Range of R, that is a value of y. Y value 1, 4, 9, 16, 25, 36. 1, 4, 9, 16, 25 and 36. Just for your reference, have encircled all the numbers. You no need to encircle. Okay, you just write 1 comma 1, 2 comma 4, etc. up to 6 comma 36. That's all. Problem number 2 is over. I'll be teaching problem number 3 in the next video. Thank you, children.